Are you ready to make multiplication feel less like a homework assignment and more like I don't know, a cool party trick? Today, we're going to dive into a few simple shortcuts to help you solve math problems right in your head, way faster than you probably think you can. Let's get into it. Okay, take a look at this. 38 times 50. Your first instinct is probably to reach for a calculator, right? Well, I'm going to promise you something. In just a couple of minutes, you're going to solve this in your head. In seconds. Seriously, just stick with me. So what's the secret? Where do we even begin? Well, it all starts with what I like to call the master key. And that key is simply understanding the power of 10. Once you get this one simple idea, everything else just clicks into place. Now, this is probably the one you already know. The simplest rule in the book. To multiply a number by 10, you just add a 0. By 100, you add 2 zeros. 1,000, 3 zeros. You get it. It seems super obvious, I know, but trust me, this is the absolute foundation we're going to use to tackle much tougher-looking problems. Okay, let's put that master key to work with our very first shortcut, multiplying by 5. The secret here is just to think about what 5 really is. It's just half of 10, right? So instead of doing one kind of annoying multiplication, we can do a super easy one, multiplying by 10, and then a simple division. So the process is just 2 little steps. First, you do the easy part we just talked about, multiply by 10. Just add a 0 to the end of the number. Then you just take that new, bigger number and cut it in half. That's it. You've just multiplied by 5 without actually multiplying by 5. Let's try it right now. What's 88 times 5? Don't even think about a calculator. First step, multiply 88 by 10. That's just 880. Easy. Now, second step, what's half of 880? Well, half of 800 is 400, half of 80 is 40. So 440. See, you just did it. Feeling pretty good about that? Awesome. Because we're about to level up using the exact same logic. Think about it. If 5 is just half of 10, then what's 50? It's just half of 100. The pattern keeps going, and the trick is just as easy. And this is where that whole power of 10 thing really starts to pay off. The method is pretty much identical to what we just did, but instead of adding 1 0 and then having it, you add 2 zeros, because you're multiplying by 100, and then you cut that result in half. It's the same principle, just with bigger numbers. And just like that, we're back where we started. Remember that problem, 38 times 50? A few minutes ago, it probably looked like a bit of a headache, but now you have the exact tool you need to solve it. Come on, let's walk through it together. Okay, step 1. Forget multiplying by 50. Let's multiply by 100 instead. We take our number, 38, and we don't do any math at all. We just stick 2 zeros on the end. So 38 becomes 3,800. Simple as that. Now for the final step, we just need to divide 3,800 by 2. So what's half of 3,800? Half of 38 is 19, so half of 3,800 must be 1,900. And there it is, your answer. 38 times 50 is 1,900. You totally just did that, and I bet it took less than 3 seconds. All right, you are on a roll. Let's tackle one more big one, multiplying by 25. Now, you can probably guess the logic we're going to use here. How is 25 related to 100? It's a quarter of 100. And that relationship, well, that's our next shortcut. So for this trick, we actually flip the order of the steps around, because it's usually easier this way. First, you take the number you're starting with and divide it by 4. Then you take that answer and multiply it by 100, which, just means adding 2 zeros. Let's use an example to make it clear. How about 48 times 25? So following our new rule, the very first thing we do is divide 48 by 4. That's a nice easy one. 48 divided by 4 gives us 12. And now for the big finish. We take our result, 12, and multiply by 100. Pop 2 zeros on the end, and you get 1,200. And that's it. 48 times 25 is 1,200. It's so fast. But I know what you're thinking. That's great for a number like 48 that divides by 4 perfectly. But what happens when it doesn't? What happens when you get a remainder? Don't worry. There is a super simple, super elegant rule for that too. And this rule for remainders is actually really predictable. It makes perfect sense. If you get a remainder of 1, that's like 1/4, so you add 25 to your answer. A remainder of 2 is 2/4, or a half, so you add 50. And a remainder of 3 is 3/4, so you add 75. Let's see how it works. Okay, let's try 21 times 25. So first step, divide 21 by 4. Well, 4 goes into 21 5 times, right? Because 4 times 5 is 20. But that means we have 1 left over. So we have a result of 5 with a remainder of 1. Now we just put all the pieces together. We take our main result, the 5, and we add our 2 zeros to get 500. Then we look at our remainder. It was 1. And our rule says for a remainder of 1, we add 25. So 500 plus 25 gives us the final answer, 525. And there you have it. In just the last few minutes, you've added some seriously powerful techniques to your mental math toolkit. This stuff is awesome. Let's just do a super quick review of everything you've learned. So let's lock these in. To multiply by 5, you multiply by 10 and then just cut it in half. For 50, it's the exact same idea. Multiply by 100, then cut that in half. And for 25, you flip it. Divide by 4 first, then multiply by 100, just remembering those super simple rules for remainders. You know, there's a great quote that says the whole point of mathematics isn't to make simple things complicated, but to make complicated things simple. And that's exactly what we did here. These aren't really tricks. They're just a way of seeing the beautiful, simple patterns that are already there in the numbers. You haven't learned to cheat. You've just learned to see the system more clearly. The real takeaway today is that math is just full of these incredible, elegant patterns. We uncovered a few of them, but there are so many more just waiting to be found. So the next time you see a math problem, don't just see a calculation. Take a second and look for the pattern. Ask yourself, what's the simpler way to do this?